This is one of the biggest mistakes students make in chemical energy sources.
Welcome to The Explainer. So today, we're diving straight into the heart of the Caribbean's energy sector, specifically looking at it through the lens of the CSEC chemistry syllabus. Understanding our local, natural energy resources, it's really not just about passing a chemistry exam. It's actually fundamentally about driving the economic and social development of the entire Caribbean region. Because when we finally grasp the molecular building blocks right beneath our feet, we literally unlock the potential to power our modern world. Okay, let's dive into this and map out our journey. We're going to start with fueling the Caribbean, then look at sources of hydrocarbons. After that, we'll zoom in on methane as the main ingredient, compare natural gas to LPG, and wrap it all up with a CSEC practice question. So, Part 1. Fueling the Caribbean, the big picture. Before we even think about drawing molecules or balancing equations, we really need to look at the CSEC chemistry syllabus rationale itself. It literally says the application of scientific principles are of significant importance in identifying, assessing, and realizing the potential of the resources of Caribbean territories. I mean, that is huge, right? The syllabus is explicitly telling us that chemistry isn't just some textbook subject. It's a vital, real-world tool for us to respond to a rapidly changing world. By applying science to resources like natural gas, we directly drive the economic and social development of the region. It's all about empowerment through scientific literacy.
And this brilliantly illustrates our next section. Part 2. Sources of hydrocarbons. What's beneath us?
So deep underground, we've got two primary natural sources of hydrocarbons that really fuel our industries. On one side, there's petroleum, which you probably know as crude oil. Think of this as a highly complex, thick, dark liquid mixture made up of countless different hydrocarbons. And because it's just so complex, it needs a heavy-duty industrial process called fractional distillation to separate it into anything we can actually use. But then on the other side, we have natural gas. And just like the name implies, it's primarily a mixture of gases. It's way simpler in its composition and requires far less separation to be useful. Now, because petroleum is just so incredibly complex, we literally have to heat it up and separate it based on the different boiling points of its components. So right at the top of the distillation column, we get our lighter fuels. Think gasoline, diesel, and kerosene. Moving down, we hit petrochemicals, and those are the starting materials for everything from plastics to pharmaceuticals. Then we have lubricants, to keep our machinery running smoothly without friction. And finally, sitting at the very bottom of the column, we get bitumen. That's that incredibly thick black residue we use for surfacing road. Let's move to our next section and see how this builds. Section 3, methane, the main ingredient. All right, we're leaving that thick liquid petroleum behind now and zooming all the way down to the atomic level of our other major resource, which is natural gas. Methane, or CH4, is the absolute simplest alkane in existence. I actually want you to visualize its structure in your head right now. Just picture a single central carbon atom. Got it? Now imagine that carbon atom reaching out and holding hands with 4 surrounding hydrogen atoms. And that's it. That simple, elegant structure is the dominant hydrocarbon component of natural gas. It's really the absolute star of the show here. So just how dominant is methane? Well, while natural gas does contain small amounts of other hydrocarbons, things like ethane and propane, methane typically makes up a massive 70 to 90% of the mixture. And because methane is a gas at room temperature and burns incredibly cleanly, it makes for an absolutely phenomenal source of energy. I mean, this is exactly what fires the power plants and fuels the industrial hubs all across the Caribbean. Which brings us to a bit of a plot twist. Section 4, natural gas versus LPG. Avoiding common pitfalls. Okay, here is a massive exam tip for you. You have got to deeply understand the difference between raw, natural fuels and processed fuels. Examiners absolutely love testing this. They want to see if you know the difference between the raw, natural resources sitting right beneath our feet and the processed fuel products we actually buy and use in our homes every single day. Let's just clarify this misconception directly right now, because students so often confuse natural gas with LPG, which stands for liquefied petroleum gas, or as we commonly call it, cooking gas. Guys, they are not the same thing. Natural gas is a raw, natural underground source, and like we just covered, it's mostly methane, which has just one single carbon atom. LPG, on the other hand, well, that's a processed fuel. It's actually a mixture of heavier gases, mostly propane, which has 3 carbon atoms, and butane, which has 4. So definitely remember this. Natural gas equals simple methane. LPG cooking gas equals heavier propane and butane. So the crucial point is knowing how to apply this. Let's move to Section 5, CSEC Practice Question. Test your knowledge. Let's see if we can apply what we've just learned. Read this official CSEC specimen question with me. Which of the following hydrocarbons is the major constituent of natural gas? Is it A, butane, B, ethane, C, propane, or D, methane? I want you to actively think back for a second to those molecular structures we were just analyzing a few moments ago.
Okay, let's walk through the logical, step-by-step deduction to arrive at the correct answer here, exactly like you should be doing in the exam room. Step 1, we recall that natural gas is one of our raw natural sources of hydrocarbons, right? Step 2, we remember that the primary gas in this mixture makes up a massive 70 to 90%. Step 3, we actively exclude the heavier components like butane and propane because we know those make up our processed LPG cooking gas. And finally, Step 4, that just leaves us to select the absolute simplest alkane on the list,
Which means our correct answer is, of course, D, methane. It is just so incredibly satisfying to arrive at the right answer through pure logic like that. Honestly, it just goes to show how easy it is to navigate organic chemistry once you truly understand the core building blocks and the real-world resources that they actually come from.
As we wrap up the explainer today, I want to leave you with a provocative question to think about. How will mastering these basic molecular structures unlock our understanding of the energy that powers the modern world? Because chemistry, it's not just formulas on a page. It is literally the fundamental language of the energy that drives the Caribbean and really the whole globe forward. By understanding a simple carbon atom holding hands with 4 hydrogens, you are looking at the very fuel of our future. So keep questioning, keep exploring, and keep building your knowledge. Until next time.
As always, the link for this study tool is in the description below. Let me know what you think in the comments.